sketch the rational function y equals x plus 3 over x minus 3. This is just a transformation of a rectangular hyperbola. However, we can do it with our new methods of analysis. So let's think about the things we need to know. So first of all, let's think about the vertical asymptote. We can see from the denominator that it will be 0 when x is equal to 3. So x equals 3 is our vertical asymptote. Looking at the top, when x is negative 3, y will be 0. So we have our x-intercept at negative 3, 0. If x is equal to 0, what we have is 3 divided by negative 3, which of course is negative 1. So we have a y-intercept, which is at 0, negative 1. Consider x tending to infinity. If x is really big, the 3's really don't matter. And in that case, we end up with x divided by x, which of course is 1. So when x tends to infinity, y will tend to 1. What about the signs of the function? We've done this with a table before. Let's do it with a number line. So we know that the value is going to change when x is negative 3, that's at the x-intercept, and the sign of this is going to change when x is 3. So these are key points. To the left of negative 3, both x plus 3 and x minus 3 are negative. Therefore, when we divide, we'll end up with a positive answer. If you're not sure, just think about x being negative 4. Negative 4 add 3 is negative 1. Negative 4 take away 3 is negative 7. They're both negative. In between negative 3 and 3, the x plus 3 will become positive. X minus 3 is still negative, so when we divide, we get a negative. And then to the right of 3, they're both positive, so when we divide, we get a positive. Now with this, we should have enough information to make our sketch. So we have a vertical asymptote, which is x equals 3. We have an x-intercept at negative 3, 0. A y-intercept at 0, negative 1. And we have the horizontal asymptote, y equals 1. Now we know that before negative 3, the graph is positive, so above the x-axis. Well, that fits with coming in from the asymptote like so. So it's going to come in from the asymptote, and then it's going to go through this point, and then it must go off down this asymptote. When we look to the right of x equals 3, we can see that it is positive. So it must be up here and do something like this.